Okay. Well, welcome back. Hopefully everyone had a safe slash relaxing slash whatever break. Now we're back to the trenches. Um, Exam go okay? A little bit better from a time management perspective. All right. Okay. So, uh, if you didn't get an email from me, I don't think you should be concerned about your grade. We had to send out midterm. They don't do the midterm grades anymore. They ask us to contact students. So um, if you didn't get an email from me, at least based on your exam, you're okay. I'll have to look at missed assignments and stuff. But okay. So I think I left an error in our code here. Let's try to remind ourselves where we kind of left off. All right. Oh, yeah, that's my thing here. All right, so we were, let me get some of the other scripts open here so I can flip back and forth between the scripts more easily. We are trying to create the thing where the room reconfigures itself based on which version of the room we should be showing for the available exits. Um, so we're going to go ahead and we're going to need player. We got room already. Let's get exit. Get dungeon. And we'll get core. Okay, so if you remember from last time, we are keeping track of the current player. So inside of our singleton, we have the ability to, at any point in time, say, who is the player? Now, remember, the player knows the room they're currently in. So we can ask the player, give us your current room. A room knows about the exits that are in the room. So what we want to do now is we want to be able to ask the room whether it has an exit in a certain direction so that we can go through and, for instance, inside of Unity, we might say, if there's an exit to the north, make sure you open that door. If there's an exit to the west, make sure you open that door. Otherwise, the doors should remain closed. So we'll probably have the doors closed by default and then open up the ones based on the exits that are in the room that the player's currently in. All right. So we were writing this code here for whether or not an exit exists. And we were talking about the idea of string literals versus memory. So that came up with this double equal sign thing right here. I think I probably asked the question of what is that operator? And that operator, the double equal sign operator, is the primitive equivalence operator, which means it's comparing the underlying value of the variable, in this case, not the contents of the string. And I think we drew some pictures of that. So, for example, if we create, I already moved some arrows around, so let me just do this. So when we say string s equals north, like this, what it does is it checks in what's called literal space and says, do we already have a string literal named north? Let's assume we didn't, so the very first time it creates that guy. So that lives at a memory address. This is an actual memory address somewhere. So if I maybe do like a 0x AB23, let's say that's the memory address for that guy. So S technically is holding a memory address, which points to a place in memory, which holds a string that says north. When I say string S2 is equal to north, again, it does that same thing. It says, is there already a place in memory, in a place in literal memory that has the string north in it? If there is, don't create it again. Instead, make this guy point to the same place. So that means S equal S2, the primitive operator here, would be true, but not for the reason you might guess it's true. You want it to be true because both of them contain NORTH, but that's not why it's true. It's true because both of them hold this memory address. So it's true because those two things are equal to each other. The memory addresses of those two strings are the same memory address, not because the contents of them is true. So if we then create a string using the new keyword, and when we use the new keyword, we're specifically saying, I want new memory. This is going to tell Java, C#, any of these modern languages is going to say, do not go and check literal memory to see if there's already a north in there. I don't care if there is or not. I want you to give me brand new memory and put north there. So this guy maybe is 0xCD44. That's a good memory address. All right. So let me get rid of this south thing here for now. All right. So now we have S3, which technically is holding the memory address 0xCD44 that I just made up, which points to a string called north. So now if I say, is S equivalent to S3, this is false because it is false to say that that string or that memory address is the same as this memory address. See how those two memory addresses are different? That's why that's false. S and S3 are not the same memory address. A human eye can see that they hold the same string, but that's not what we're comparing with the double equal sign. Now, in our particular case, when we were writing this code, I would say the important tangent we went on to here is in our particular case here, this actually will work. But the reason it works is because we're comparing the memory addresses, not the contents. Every single time we created a direction, we didn't say new memory. We said, oh, this is to the north, this is to the north, this is to the north, this is to the north. All those norths point to the same single memory address, which is why we can say, well, if this string literal, for instance, north, is equal to this string literal, north, it's their memory addresses are the same, not the contents. But imagine for a programmer that doesn't know what's happening under the hood, how that can get you into trouble. In this particular case, since we controlled all of the string literals that we ever wrote, we know we never asked for new memory. Therefore, it's always using the literal memory space, and it won't have more than one place, more than one literal memory location with the same string. But what we really should do is, because of what we want to do is compare the contents of the string. We want to look at the string class in C# and say, how do I compare a string to another string in terms of the contents of the string? So let's go and look up C# string class. See how good Microsoft's documentation is this year. All right. Oh, this is always a fun one. It's something called a sealed class, which means you can't change it. Like you can't, there are these things where you can extend a class to make a class more than it originally was. Effectively the same thing you can accomplish with inheritance, but by making it sealed, I think effectively, I don't know actually all the rules it follows, but it effectively says you can't do that. If you want to make a super duper string, you got to extend string or inherit from string in this case. Okay, so let's go and look at what methods we have. Here's our compare. This one's very promising. where we can compare two substrings of, well, there's several different compares. So this is polymorphism, right? Bunch of compares that do different things. Let's see if we get down to like an equals. Equals. Let's see. Determine if two specified string objects have the same value. Okay, this is actually going to be two specified string objects. Let's look at this guy right here. So here's a method called equals that takes in two strings. It tells me, it says, determines whether two specified string objects have the same value. So before we click on this, and I don't know what we're going to see. I haven't looked at this documentation in a long time, probably. If I have to provide this equals method with the two strings I want to compare to see if they're the same, do you think that that method's going to be a static method or a non-static method?
Static.
Static. Okay. Because by the way we're seeing it being used, we're kind of looking at it as being this like string equivalence factory, right? It's a single function that sits there. I have to throw it both strings that I want it to compare, and it will tell me true if they're the same and false otherwise. As opposed to if it was a instance or a non-static function, we would only need to give it one string because whoever's equals method we called would already know about the value of that guy. All right, so let's see if C# actually makes logical sense. So let's click on, on this guy. Let's see, do we get some oh, that's a different one here. This is using a string comparator. I can't find the place where it's defined. Let me go back to this. I might have scrolled off. Ah, there we go. All right. So we see that we predicted correctly. This is a static method. How do we call static methods? Using the name of the class in which the method was defined. Okay, so that's the string class that owns this guy. So this will be string dot equals. We pass it to strings. This is actually an interesting thing you see in some more modern programming languages. See this little question mark here at the end of our type? Built into a lot of languages now, this is kind of somewhat of an evolution of exception handling, where languages will do null pointer exception checking for you, as long as you write your classes the correct way. So this question mark there basically says that it is possible that A may hold nothing, might hold null. It is possible that B might hold null. So whenever we go to use either of those, the language would police itself against the exceptions and not have your program necessarily crash. It doesn't work as well as you maybe want it to work, but it's an effort in that direction where it makes the programmer at least pass through that idea of, will I always have a live object, or will sometimes somebody send me an empty object, an object that doesn't have a value, therefore it's a null pointer, and I shouldn't be calling methods on a null pointer, right? If I say, if we have our player P, and I say P.getName, well, getName is only going to get me the name of that player if I've set P equal to a player. If P is not equal to a player yet, its default value is null. And if I start asking nothingness to give me its name, bad things happen. Programs crash. Null pointer exceptions happen, blah, blah, blah. Okay, so our newer languages are kind of force the programmer to be aware of that possibility as they're writing their code, if you want to. Kind of falls into the same category when we talked about interfaces in Java, where we can say that we want a class to implement a specific interface, which is kind of saying we want it to follow a standard. Like we looked at the runnable interface that worked with threads. And the runnable interface was incredibly interesting. It basically said, if you're runnable, you must have a single method called run. So if you are going to be something that follows the standard of runnable, you have to write a run method. So the programmer can choose to say, well, I'm going to police my code. I want to make sure everything's compatible as I'm writing it. So I'm going to build this interface. I'm going to say, oh, I have a bunch of stuff in my program that needs to be runnable, which effectively says it needs to have a run method. I'm going to make sure when I define each one of those classes, I mention that this class is to implement runnable, which means that if I forget to write the run method for one of those classes, it'll scream at me and say, this class does not follow the rules associated with the runnable interface. That's the purpose of those interfaces. Now, the reality is that most programmers, I would say most of the time, including myself, um, isn't going to do that. They would just say, oh, I'm only writing 3 objects. I'll just make sure they all have a run method. No problem. I won't throw the police officer out there to constantly check up on me, forgetting that maybe 2 years in the future, I go back and make a change to this. Maybe I make a change to whether it's the interface or one of the classes and it falls out of compliance. Now all of a sudden you're not going to get that warning message because you didn't take extra care later on, or take extra care initially to make sure you were policed, I guess. Okay, so this tells us how we're going to call this guy. So we can compare 2 strings to each other by passing the 2 strings. It gives us a Boolean. Let's make sure we see the name of our class here. This is string.equals. So in C#, this is a capital. It's in the system namespace where it comes with those things. Here's the classes in there. Let's just make sure it's a capital S for string. It is. So what we would say here is string dot equals like that. That's a capital S. So if string dot equals this string and this string, if they have the same contents, we will return true that this exit exists. Make some sense? If we've checked all of our exits, we're going through, we know any room has a current number of exits because we created a little bucket, an array with 4 buckets in it, that so every room can have up to 4 exits, but not every room has 4 exits. So we have to keep track of every single time we add an exit. We have to add 1 to the number of exits we actually have. So this for loop says, go through all the exits that exist in this particular room. For each of those exits, ask the exit, give me your direction. Since this guy here is an instance of exit, we would expect get direction to be a non-static method. We're calling it with an instance of the exit class. So we want this exit to give us this direction, and we're going to compare it to whatever direction was passed in to this has exit function. That makes sense? Okay, so this is a tool. We have added this little ability to the room class that says, if you give me an exit, I will tell you whether there's an exit in that direction in this room. All right. So now let's go and see where we were using that. We were writing that for a reason. Let's go find what that reason was. All right, so remember we have this objects folder inside of our scripts folder, and what I did is I put in that folder, remember in Unity, it doesn't care about your organization, but for me, I'm going to say the stuff I put into my objects folder are going to be my things that are not mono behaviors, the things that don't hang off of game objects. These are the things I'm using for logic. Remember, we have this room manager script, and this guy is a mono behavior. Mono behaviors need to be attached to game objects in order for them to run. And we happen to attach it to this game object that's sitting here in our scene, just called room manager. And this guy is a very boring invisible game object. All he has is a transform, and then he has this room manager script attached to it. That room manager script has our 4 physical doors that are here dragged into it. So we have access to that in an array. So if we go into our room manager script, this guy right here, when this room starts, when this script starts, we're going to go ahead and we're going to build the player. Now remember, what we're doing in our game here, which is just an implementation decision we made, is we're going to say, you know what, there's only going to be one actual room scene. And then what's going to happen is as the player makes decisions, that room, that single room that already exists is just going to reconfigure itself. It'll change the exits that are being shown and things like that. So remember, with that in mind, this start function here will only ever be called one time. So what are we doing in here? We're creating our player. We're letting our singleton know about it. We're creating our dungeon. Our dungeon's going to be a local variable that our room manager keeps track of. We could have thrown it up in the singleton. It's possible we'll move it later, but right now, let's just say that we only need the room manager to keep track of that. We're going ahead and printing out that player's name just to prove that we had it. I think we can dump that. All right. Then we're going through and we're setting the initial doors. So we're going through all of our doors that are in this room, and we're setting them active based on what we currently have in core, which is just 4 variables representing our rooms. This is what we want to update. We want the room to now show us the exits associated with the player's current room they're in. All right. So, oops, sorry. I don't want your help. So here, just so we have the error messages in the right places, we'll go ahead and get rid of those. I'm no longer going to keep track of my hard-coded exits inside of core. We're now going to ask the room that the player's in if they have certain exits. So let's go back into our room manager. Maybe what we do initially is we have a function in here. Maybe this guy is private. And let's call it, we'll say void. Maybe call it reset room. Oh, what did I think I wanted to do in there? Let's see what the code guru. Oh no, it's trying to set the global variables I deleted. Can't trust this AI crap. All right, so what we want to do is we want to go through and set all of those rooms. Let's set them all to true. So that we have to decide, do you want there to be a door when there's an exit in that direction, or do you want there to be a hole when there's an exit in that direction? Maybe a door makes more sense because otherwise, because right now my walls are empty walls. All right, so by default, we'll turn the doors off. So we just have this function called reset room that whenever we call this, it turns the doors off. Then we can go back through and update the doors the way they should be updated. All right. So we'll go ahead and we'll do an initial this dot reset room when this starts, which should turn all the doors off. I'm going to delete some of this extra stuff here. I have a feeling I'm going to be disabling this AI thing pretty soon. I don't like all the extra typing it's doing for me. All right, so when this game object first starts, we'll go ahead and reset the room, just turn all the doors off, because as we've designed it, by default, the doors are all on, just so we can visibly see it for our design, right? All right, so we'll turn them off. Then we want to go ahead and we want to have a function, maybe called private void set current doors. Or let's see, called setup room. Yeah, let's do that. All right, and what setup room is going to do is it's going to go through and it's going to get the room that the player is currently in. Who knows about the room? Core does. Or who knows about the player? Core does. So we're going to say core dot the player, because this is static. Here's a player. We then have a function called get current room. So let's go ahead and just grab that. So we have that as our starting point. So I'll go ahead and I'll say room current room. Okay, we're at about a 20% success rate so far. All right, so room current room. Now I want to go through all my possible exits. Now, since there's only 4, we could do this just as 4 if statements. So we can go ahead and we can say, I'm going to take those 4 lines, but instead of just setting them all to false, what is this, north, south, east, west? Let me confirm that. Room manager, north, south, east, west. Okay. So we're going to ask the current room that has exit to the north. It's just terrible. Current room that has exit to the south. I did. I don't like it. Well, no, I mean, it's correct. But put yourself in those shoes. You're not getting the practice of typing this stuff. There's east. And here is west. I think you would benefit greatly from typing this stuff yourself. I would disable the AI stuff. All right. So we are going to set whether a room is active based on whatever the current room has exit on north returns for us, which is the function we just wrote. So inside of room here, we wrote this function, has exit. If we pass it a north, it's going to go through all the exits in that room, find out if any of them is equal to north, and return true if it does. Otherwise, after it's checked all the exits, it'll return false if it never found an exit to the north. All right, so that's what setup room will do. We know that we can set up that room right after we create the dungeon. If you remember, inside of our dungeon, this is where we added the player to the very first room. And when we set a player for a room, the room also lets the player know about their current room. So really, we could not call reset room. I guess it doesn't hurt anything to call it. But really what we want to do is called setup room. We'll leave reset room in place just in case we ever have a we'll put a little comment before this guy. This basically turns all the doors off. So this function says disable all doors. But that's only if we ever need that. Because really our setup room, this guy will show the doors appropriate, blah, blah, blah. You didn't fix that for me? It did. Appropriate for the current. Okay, I like that part. I'm okay with that. Just don't code for me. All right, show the doors to the appropriate to the current room. All right, so doing this that first time should give me just a single door to the north, right? There's my single door to the north. All right. Now, just to experiment with it just a little bit, even though this will technically break our memory chain we talked about last time, I'm just going to jump into my dungeon. And what is it? Room one, two, three. Three is the one that has all four exits. I'll just go ahead and throw the player just arbitrarily into room three. So now when I run my code again, it should now show me all four doors. Okay, so because right now he's in room three. If I go to room four, I should just have a door to the east. There's my door to the east. All right, we've exhaustively tested this, must work perfectly. All right. Well, now we need to have a way for our player to move throughout the world, right? Just so I don't forget, let me throw them back into room one. Remind me, if I had put them into room, well, actually, I think we were still actually okay. Because all these rooms are local variables inside of Dungeon, specifically local variables inside the constructor for Dungeon. The idea here would be that all those variables die when that constructor ends. But we saw that they actually still exist because room manager is holding on to the dungeon, and player has been put into the very first room of that dungeon. Core holds that player. Player knows about room one, so room one won't disappear because remember these are called pointer counters. When we are inside of dungeon, there is currently a single pointer counter to R1. Now there's two pointer counters to R1 because our player becomes aware of R1. When this ends, the program counters for R1 goes from 2 back down to 1. Only the player knows about it. But as long as it's greater than 0, automatic garbage collection is not going to clean it up. What about the rest of the rooms? Well, R1, which the player knows about, he knows about R2. R2 knows about R3. R3 knows about all the other rooms. Okay, so our rooms stay in existence beyond what's obvious about scoping rules. Scoping rules would tell us, hey, don't make these local variables because when this constructor is over, those variables all go away. And I assume you want your rooms to exist. But there's actually another thing that points to those variables hidden inside of the chain started by our player in room one. Make some sense? All right, so the scope is still there because the player has access to it. And that's good programming practice because we certainly don't want to have all these hard-coded rooms laying out there in memory if they don't otherwise have to be. And we don't want it to be crowding up our core. We don't want it to be crowding up the top here. We're going to create it because all we really care about is the memory addresses. We need those values to exist. And then we need a way of getting to those values. So as long as we got a pointer, we don't need R1. We don't need R2. We can get player's current room to get to that room they're in. All right. So now what we want to do is we want to decide how our players should navigate the world here. I think we used arrow keys in the previous thing. I'm actually not going to use the system thing that was built in. We're going to respond to key presses instead. Unless that ends up being too much of a trouble, then I won't do that. But let's go and look. I think it's called like key down or something like that. So Unity key presses, get key down. All right. So inside of update, for example, we can use the input class, ask if a key has been pressed down, whatever key we want to have. Then we can respond to it appropriately. All right, so let me go ahead and steal this and let's kind of mess with this at the debug log level. Yep, it's built into input. So here inside of Room Manager, which is our one mono behavior involved here, right? We'll go down to update, which is currently doing nothing. And let's go ahead and ask a question. We'll say if input.get key down. What were you gonna do? The whole thing. Look at, well, it's doing the WS DA controls. Okay. All right, so we're gonna ask the question if, for right now, let's just press the space key. What did you do? Okay, good. Does anybody know how to turn off? Options settings. I don't see an option settings. Settings. Maybe it's an extensions. Copilot.
Yeah, that's
All right, let's see if that makes him shut up. Well, we don't know we succeeded yet. All right. All right. So we want to maybe do like an arrow up, arrow left, arrow right, something like that. So let's make sure we're able to detect that. So let's do because there is a key class, yeah, key code. So we can look at this key code class. And inside here, we should have a list of all the different keys. Here's numeric keys, left arrow, right arrow, up arrow. Okay, so we want up arrow. The 2 words, 1 word, 1 word. And then we'll do debug.log up arrow. Oh, whatever. Yeah, it's fine. I'm going to be deleting it anyways. Were you there helping me on that one? Copilot was fixing my spelling too. We're all in trouble. All right. So now I'm going to run this again, and we should be able to press the up arrow and see it spitting out to the screen that we pressed the up arrow. All right. So let's just make sure that we are correctly responding to that. And I'll go to the console here. And it is doing it. It says up arrow is unknown. Oh, because it's called key press.up arrow. Sorry. Or key code.up arrow. It's not a string. All right. So now, we'll run this again. Right, there's me pressing up. It didn't like my string I passed it, but It is responding to me hitting the up arrow. All right. Presumably the left arrow, right arrow, all that stuff would be the same. So if we hit the up arrow, we want to try to go to the north. Else, if we hit the left arrow, try to go to the west. Right arrow is to the east. Down arrow is to the south. And we could maybe make the argument to do this in a fixed update, I guess, but whatever. Update happens every frame. Fixed update potentially if we had super duper fast reflexes, we might miss a key press, I suppose. All right, so every single time that we have a frame, we're asking the question, did the user just press one of those arrow keys? And if they did, we want to take that exit. All right, so if they press the up arrow, we want to try to take the exit to the north. What does it mean to take the exit to the north? Well, the player is in a current room. We already have built into this the ability to find out if it has an exit. We could go ahead and make that guy private. We might decide to loosen it up later because maybe we have some other aspect of our program where we do want to just be able to ask a room, do you have this exit? Actually, we already had that, so it does need to be public, right? Yeah, we are already using it. So we're not going to do that, but we will still make this, we're going to still add another function. In this particular case, when the player hits the up arrow, we don't necessarily have to say, well, if there's an exit to the north, then go ahead and send them to the north. We can instead say, player grabs the room they're currently in, just tries to take the exit to the north. And if there's an exit there, it succeeds and removes himself from the current room and puts himself in the new room. Otherwise, he suppose bumps into the wall and there's no exit in that direction. So we're going to have a public void, call this guy try to take exit. This will be to a certain direction. All right. So here we'll ask that question if this dot has exit to that direction. So we're still asking that logic. We're just embedding it inside of the room rather than having all this code hanging out here inside of Room Manager. So basically the player's just going to say, okay, I have a room I'm in. I'm going to try to take an exit to the north and just see what happens. So if the room the player's currently in has that exit, we'll do that. Otherwise, we can go ahead and I'll just throw an else in here. So for debugging purposes, and we'll say debug.log no exit in this direction. We'll see what it actually wants from me there because it seemed to do an object thing before. But all right, so if there's an exit in that direction, then we want to go ahead and take the exit in that direction. Did we already build that into room? Maybe to exit. What does exit have? Exit, we can get the direction for an exit. An exit has the destination room. Okay, so what we want to do here inside of has exit, if there is an exit in that direction, remove the player from the current room, place them in the destination room in that direction, update the room the player is currently in. So the room exits visually update. Make sense? So for our homework, and I will see GitHub desktop. I need to update the code on here. I had my computer crash on me. So let me get to the mud one. That one. Oh, because where you need to go inside that, because I'm only doing scripts folder, right? Assets, scripts. There we go. All right, so it's showing me I've made a bunch of changes to these things. I'll go ahead and say updated for homework. Okay. I'll go ahead and grab the link again just so you have the fresh code. Homework, we have given current state of code. We want to finish writing inside of room, try to take exit. So try to take exit method. So I'll figure out why that's doing it. Is it inserting something or whatever? I must have pushed the funny button. Okay, so submit your GitHub repository to your scripts folder that should have any changes to room, as well as if you need to go make changes in other places, do that as well. But really, you're starting with the try, take, exit function and follow the yellow brick road to effectively allow you to have your player walk around our dungeon, having the room change configurations every single time we move through a door. Make sense what I'm asking you to do? All right, so I'll put this homework up. My GitHub repository is already up to date. It'll be in the assignment like I have here, and I will see everybody on Wednesday.